Hello everyone. This is the last part in a carboxylic acid. Here we will discuss the carboxylic acid derivatives. We know that the general formula for carboxylic acid is RCOOH. Here the OH group, it can be replaced by a different group such as alkoxy. Then we get here a ester which is having a formula RCOOR. OH is replaced by OR. The example is ethyl acetate. When this OH group is replaced by NH2, we get a amide, and general formula is RCONH2. Example is acetamide. So this is about the ester and amide. Now come to this side. Here we are going to discuss in this video the acid halide derivatives and acid anhydride derivatives, their methods of formation and chemical reactions. So now, what are the acid halide derivatives? What are the acid anhydride derivatives? Then come to this. When the OH group is replaced by a X, here X is nothing but the halogen. Then we get acid halide derivatives, which is having a general formula that is RCOX, and the example is CH3COCl, that is called as a acyl chloride or acetyl chloride. Whereas if the OH is replaced by OCOR, then we get anhydride derivatives, that is RCOO COR. The example for anhydride is acetic anhydride, that is CH3COO COCH3. So we will focus on acid halide derivatives, that is acid chloride, its methods of formation and chemical reaction, as well as acetic anhydride, its methods of formation and of chemical reactions. So turn towards acid halides. Acid halide derivatives, in which we will see the acetyl chloride, its methods of formation. The structure for acetyl chloride is a CH3COCl. The acetyl chloride, it can be prepared from acetic acid and phosphorus trichloride, or by acetic acid and thionyl chloride. So in the two methods, common reactant is acetic acid, and in addition to this acetic acid, we have to use either PCl3 or SOCl2. See the first reaction. Three molecules of acetic acid reacts with the phosphorus trichloride under heating condition gives acetyl chloride, and there is a formation of phosphorus acid. Look here, three chlorines are present. That's why we have to use three molecules of acetic acid, and it will give three molecules of acetyl chloride. In the second method, when acetic acid is treated with the thionyl chloride, it gives acetyl chloride along with the sulfur dioxide and hydrogen chloride. From this OH group, the oxygen is joined to the sulfur, whereas the hydrogen is joined to the chlorine, and one chlorine, it will take the place of OH group, so that here we get acetyl chloride as a product. Now we will see the chemical reactions of acid halide derivative, that is the acyl chloride. Before starting with the chemical reaction, just see how the reactions are written here. It is the action of water, first reaction. It is the action of ammonia, second reaction, and third reaction, it is the action of alcohol. Of this, the action of alcohol, we will see the mechanism of action of alcohol, that is the esterification. So the first reaction is the action of water. Here there is a presence of Cl. It can be replaced by a OH group. When it is happen? When the acetyl chloride, if it is heated along with the water, then From the water, HOH, that is OH group, will attack on this carbon, and there is a removal of Cl. It will combine with the hydrogen to form HCl, and here we get the acetic acid. So this is the simplest replacement of Cl by OH. It is also called as the action of water. Similarly, the Cl group, it can be replaced by NH2 group if the acetyl chloride is heated along with the ammonia. It is called as a ammonolysis, and here we get acetamide. And in the third reaction, the Cl group is replaced by a alkoxy group from the alcohol. Here the alcohol is C2H5OH, alkoxy group is C2H5O minus. It will replace the Cl, and here we get ethyl acetate. So in the chemical reaction, just we have to replace the Cl either by OH group, either by NH2, or by OC2H5. OH, it is called as the action of water or hydrolysis. NH2, it is the action of ammonia or ammonolysis. OC2H5, it is the esterification or action of alcohol. Now we will see the esterification reaction in a detail, a general reaction as well as the mechanism of esterification. Esterification reaction involves the formation of ester from acid and alcohol, or acyl chloride and alcohol. Here the acetyl chloride, it reacts with the alcohol to form ester. It is the general reaction. See here, a Cl group is replaced by OR group. Here I have written RCOOR. It is the SCl. Now the mechanism of this reaction. In the first step, this lone pair present on the oxygen, it will attack on this carbon, and the bond between the carbon and oxygen, it will shift the electron on the oxygen, so that here we get oxoanion, as well as the oxygen is having a positive charge because it is having a 3 valency. Then in the next step, this electron, they came back with the removal of Cl. The hydrogen is eliminated as a H plus. So here there is a H plus ion, and here there is a Cl minus ion. They will combine to form SCl, and remaining will be the RCOOR dash. This is the ester. In this way, esterification occurs, and we get a corresponding ester. Now, after the acetyl chloride, we will see the acid anhydride derivatives of carboxylic acid. Now look on the screen and take a screenshot, then I will explain. So let's begin with the anhydride derivative. Here we will see the acetic anhydride. The formula for acetic anhydride, here it is written. It is prepared from the acetic acid, as like the acid halide derivatives. When two molecules of acetic acid, I have written these two molecules separately, here in a black color, here in a green color. Now this acetic acid molecule, when they heated in presence of phosphorus pentoxide P2O5, then there is a removal of water molecule with the formation of acetic anhydride. Here hydrogen from this OH group and the second OH group from the acetic acid of second molecule, they combine with each other to form a H2O. It is eliminated, and the remaining fragments, they join together. In this way, there is a formation of acetic anhydride. So this is the simplest reaction, just the combination or reaction of two molecules of acetic acid in presence of P2O5. Now the chemical reactions of acetic anhydride. Action of water once again, action of alcohol and action of ammonia. All the three reactions that we have seen in the acid halide, similar reactions that exhibited by acetic anhydride also. So the acetic anhydride, when it reacts with the water under heating condition, then this CO bond and this CO bond, it will broken down to form acetic acid molecules. That is two molecules of acetic acid. It is called as a hydrolysis. So upon hydrolysis, the OH group, it will attach to this carbon with the breaking of this bond, and hydrogen, it will attach to this oxygen. So CH3COOH, CH3CO. This is called as the action of water on the acetic anhydride. Then the second reaction, action of alcohol. We know that OC2H5 group is there, OC2H5, O minus is there, and H plus ions. So it will attack on the carbonyl carbon, and here there is a formation of ethyl acetate. Suppose it will attack here, then this bond will broken down. Then here we get a CH3CO, OC2H5, and then a CH3CO, O minus. And this O minus will join to the H plus, so that here we get the ethyl acetate and acetic acid. Now in the third reaction, ammonia will attack on the carbonyl carbon and it will form acetamide and acetic acid. So from these three reactions, it is clear that it may be a hydrolysis, esterification, or ammonolysis. We have to check which reagent is used. Suppose water is used, so we have to split this water into H plus ion and OH minus ion. Then what we are going to do, OH minus ion, it will attack to the one of the carbonyl carbon, and H plus ion will attach to the oxygen here. Similarly, in case of ammonia, we will split this ammonia as per our convenience, H plus and NH2 minus. This, it will attack on the carbonyl carbon here. So at this place, NH2 will attack and the hydrogen will attach to the H. So that here we get CH3CO NH2 acetamide and a CH3COOH, that is called as a acetic acid. So these reactions are called as the hydrolysis, esterification, and ammonolysis, depending upon the reagent used in the reaction. So this is all about the acetic anhydride, its methods of formation and chemical reaction. So in this video, we have seen the acid halide derivatives as well as acid anhydride derivative. So with this topic is completed, and if you have any doubts or any query, you can write me or you can tell me at any time, so that we will solve that query before the exam. So we'll stop here. Thank you very much.